Okay, Bhute. So good evening, and we are in the last part of our first book now. So basically, changes in matter, right? Changes in matter. We have learned about status in matter, status of matter, actually, status of matter in previous grades, grade 6 and 7. And we just learned, so there are three status, basically solid, liquid, and gas. So I think that you can remember the stuff. If not, I can just make you remember that certain things that we have learned. Just basics. So with physical or chemical property changes, the matters changes status different time. It will have different status, and even it can be break down into different compounds and the different status. Maybe keeping the same compound, so it can change the status, like water. So water is basically when you heat that, it will become gas, but still water or water vapor. So water, when you cool down, it will become ice, but still it is water, right? Without changing the chemical, property, like it remains as water. It is always water. It remains as water, but it changed the status. That can happen like, the status of matter, status changes can happen with some reactions too, right? State changes can happen with some reactions too. So let's see them first, and let's so basically you can see, so there are three status, like this. I'm using this interactive simulation again to show you this. Okay, you can see here when you change here, so these are the you can call them molecules or compounds that made up an object, because we learned the discontinuous nature of this matter. It is also, I think we have learned in the grade 6 previous grades. Discontinuous nature means like it is matter is made up with some small particles, small objects having similar properties, and there is a gap between these things. Therefore, even like, because the diffusion sometimes object moving, so can happen, like, or other components can move through these things, right? You can see here in this one, so these are the compounds made up the matter. So just don't think much about this, whether this is in solid status, gas status, or but here you can see it is neon. Neon is basically a gas. So gas, if it is there in a container, so what will be the shape taken by gas? What is the shape? Does it having a shape, a definite shape, or not? Gas?
Gas haven't a shape, sir.
Yeah, it's not having a definite shape, right? But what will happen actually, it will take the entire space of the closed container. If it is put into a closed container, it will move here and there, everywhere, right? When you increase the heat, you can see the motion is, so let's increase the heat, and when you heat it, you can see it's moving rapidly, right? It's moving rapidly. But so if the container is closed, you can see now it is like 50 Kelvin. So this acting as a gas, it's moving here and there. The components are loosely coupled. These compounds are loosely coupled, or the compounds having very loose bonds. So it can be easily break down. Therefore, it's moving here and there and expand into the entire space, taking the entire space. Therefore, not having a definite shape. So this is when, you can see this temperature is around 200 kelvins. So temperature can be measured in like few measurements. One is Kelvin, so another one is Fahrenheit, another one is Celsius. Right there, I hope that you know the relationship between Celsius, Fahrenheit, and also Kelvin. You can just change this to here. So 198 Kelvin is the equivalent temperature is 75 minus degrees 75 in Celsius. So what is Celsius 0? How many Kelvins? Celsius 0. So what is the Kelvin value of Celsius 0? Yes. Hello.
200 73 kelvins.
400 or 300?
200, sir.
200. Yeah. So there is a. So you can just increase this. You can see when you're increasing. So let's increase this heat more, and I just need. Okay, now you can see it's raising up to 0 Celsius. Let me stop there. When it's 0 Celsius, you can see the Kelvin value. Let's see the Kelvin value. It is 274, right? Then 0 Celsius means how many Fahrenheit? 0 Celsius, how many Fahrenheit? Yes?
37 or 32, sir.
32, right? Okay, so I hope you know the Celsius to Fahrenheit conversion. So let me go back. The Kelvin is like, Kelvin is this, and Celsius to Fahrenheit, like you have to divide by 9, divide by 10, add 32 to that. So Celsius to Fahrenheit. Celsius to Fahrenheit, you can see 0 is 32. How it happened? You have to divide, you have to multiply by 9 divided by 5 plus 32. That is how the value comes, right? So Celsius, you have to multiply by 5 upon 9 and then add 32 to that. When it is 0, it is 32, right? But when it is 1, it is not 32, it is 33.8. How it happens? Because you have to multiply by 9 and divide by 5, then add 32 to that. That is how the Fahrenheit conversion happens. But please remember this equation. Celsius into 9 divided by 5 plus 32 is equivalent to the Fahrenheit. And then Celsius to Kelvin or Kelvin to Celsius. Right? Basically, there's a fractional value 207, 0 Celsius plus 273. You have to add 273 to get the Kelvin. That means like if you're having 100 Celsius, it is 300 Kelvins, 373 Kelvins. Because you have to add 273 to that. Okay. Anyway, in the room temperature, you can see this neon is a gas in the room. Not this, sorry. That's my simulation. Okay. Neon is a gas in the room temperature. This is not room temperature even. 0 Celsius is not a room temperature. You have to increase this to 25. So anyway, it is acting as a gas. When you cool down this, so what will happen when you cool down? Let's cool down. Let now minus degrees of Celsius, you can see. So let me reduce the, I'm cooling this down further. Now minus 50, 60 degrees, but still you can see it's behaving as a gas. So let me cool down further. If you need, I'll send you this link. We can try with different material, different things like neon is there, argon is there, oxygen is there, water is there, H2O. We can try all. You can see now motion is limited, but still gas. Why? Because it is taking the entire container. So it is gas. Even in 200 degrees of minus 200 degrees of Celsius, still it is gas. Further, I'm cooling down. When I cool down this further, what will happen? The motion will be limited and there will be a limited motion. So what will happen actually? What's going to happen next? When this motion is limited, what will happen? Yes? When you cool down this, the motion will be limited. Actually, as a result, what will happen?
It becomes its solid state.
Solid or liquid first? Gas? Normally gas become liquid, but there are like situations where the solid become gas and gas become solid. There are situations, but normally gas to liquid, right? Normally gas to liquid. Okay. Solid is having very limited movement. In solid, the bonds are strong and the movement is like, you can see still it is gas, but now it's going to become a liquid, right? So let's cool down further. Okay, when there are no minimum motion, then when it take the shape of the container, it's having a definite shape, but the thing is the shape is changing based on the container. It takes the container shape, so it will become a liquid. And if you further cool down, so it can even become a solid. So that is how the matter changes. So let's see with a familiar material like water. So this is, you can see 127 minus degrees of Celsius. What is there? What can you see? Is it solid, liquid, or gas? This is 127 degrees of Celsius, but minus. Yes?
Liquid.
Liquid. This is water. When you drop this, drop the temperature to 0 Celsius, what will happen? වතුරේ උෂ්ණත්වය බිඳුවට බැස්සුවම මොකද වෙන්නේ? බිඳුවට අඩු වුණාම.
It will convert into solid state.
Solid වෙනවා නේද? Solidify වෙනවා. ඒක මේ මොනවද වෙන්නේ? ice හැදෙනවනේ නේද? බිඳු වුණාම. Hello?
Yes, sir.
It will convert to ice, right? So ice is a solid, right? Ice solid, ice can solid. Okay, kiyati the liquid when? So what is the temperature that it will become liquid? Yes, what is the temperature? In which temperature it will become liquid? Yes. In which temperature? We learned this in grade 6. Yes, Pute? I'm asking about water, very simple question.
100 Celsius.
Oh, is it
0.
0, right? So that is the melting point, right? Zero is the, right? 0 is the melting point. Like, so when it passes 0, right, in the 0 Celsius degrees, yes, it can be kept as solid. But the thing is, when you are, so that is the melting, that is the place where it start melting, right? Let's see what will happen when you increase the temperature a little. I'm increasing this to, okay, 96 degrees now. Okay, it is 46 and 37. So let me make it okay. Still, you can see there is a motion, but this motion is limited, right? This motion is limited, so it keeps the shape. It keeps the shape. 10 degrees. Okay, 7 now. 7 degrees of Celsius. Let's reduce 5, 3, 2, and so this is 1 degrees of Celsius. You can see now it is basically taking the shape of container. But if you drop this further, it's not getting the shape of container. Instead of that, so it can take the shape of container because I'm just freezing it. But normally what will happen, when you increase the temperature, you can see the movement will be more. There will be more movement. So this is 15 degrees. This is the room temperature. You can see there is a fast movement. But when you increase this to 100, okay, now 70, 80, 90, okay, 96. Okay, you can see something going on, right? Still, but this is called boiling, right? This is called boiling, but still not properly boiling. Still not properly boiling. Let me increase. Now it is 100 degrees and you can see it's becoming gas. Right. When it is more than 100 degrees, it spread to the container, taking the entire space of the container, becoming water vapor. This is gas. This is called boiling point. 100 degrees is called boiling point. Right, in water, 100 degrees is boiling point and 0 degrees is melting point. In the melting point, the state change happens from solid to liquid. In the boiling point, the state change will happen from liquid to gas. Okay, I hope that you can remember the idea. The nature of a solid is it's having a shape, it's having a definite shape. Nature of a liquid, it takes the shape of the container. You can see nature of gas is everywhere. Nature of solid, it has a shape, but the shape is changing. There are minor changes, but these minor changes you can't see it, right? Solid වලත් ජල අණු පොඩ්ඩක් එහාට මෙහාට move වෙනවා. බලන්නකො solid තියෙනකොටත් මේ ජල අණු නෙමෙයි ඕනම අණුවක් පොඩ්ඩක් එහාට මෙහාට යනවා. හැබැයි ඒ වගේ relative position එක වෙනස් වෙන්නේ නැහැ. ඒ කියන්නේ එකකට සාපේක්ෂව අනිත් එක. When you compare this relative position one compared to another, the relative position is not changing. හරි relative position එක වෙනස් වෙන්නේ. Relative position is not changing. ඒතර එකකට සාපේක්ෂව අනික පොඩ්ඩක් හෙලවි හැරි එතනට වෙලා ඉන්නවා. හෙලවි හැරි ඔයාලට පේනවා එතනටම වෙලා ඉන්නවා. තැන් වෙනස් කරලා වෙන තැනකට යන්නේ. That is the solid. But I'm telling it in Sinhala for better understanding, but if you cannot understand, tell me, I can explain it in English also. So what is here in the solid? The nature of solid, the compounds that is made up with, you know, there are small components that it made up with. Here, actually, it is H2O, 2 hydrogens and 1 oxygen. That is H2O, right? That is the compound. The relative position of H2O is not changing, no significant change in the relative position. That is solid. But in the liquid, you can see, so here, it can move to some other positions. There can be relative position changes. එකක් දිහා බලන් ඉන්න එයාගේ තැන වෙනස් වෙන්න පුළුවන්. එතනම තියෙන්නේ නැහැ. It can move to some other place, but this is not regularly happening. හැම වෙලේම වෙන්නේ නැහැ, but කොහොම හරි පොඩ්ඩක් එහාට මෙහාට වෙලා සාපේක්ෂව වෙනස් වෙන්න පුළුවන්. Here you can see it was here, but now it is here. The relative position has small here, now it is here. The relative position has small change. That is not a massive change, but small change. That is what the liquid is. But gas is change in the relative position rapidly. You can see change in the relative position rapidly. Okay. Are you okay with the status now? Can you remember what we have learned in the previous grades? And about the discontinuity of this matter, and also the relative position changes, the shape?
Yes, sir.
So let's move to the lesson now. In this lesson, we will first learn, right? We will first learn whether there are physical changes or chemical changes in matter. So we are going to learn whether there are any physical changes or chemical changes in a matter. Okay, so since you are coming to the to IT class, I would like to ask a small question. So we are using colors in computers. So one is screen color, the other one is printer color. Are they same or different? Screen color, printer color, are they same or different?
Difference.
Different. Then tell me, so what will happen when you try to print something, and what will happen when you try to display something? Which is physical reaction, which is chemical reaction? Yes, when you try to print something, is it physical or chemical? When you try to, so I'm asking about the colors. Is it physical or chemical? So what will happen if you try to display something? Is it physical or chemical?
Chemical.
Which one is chemical, which is physical? Both are chemical. Both are chemical, or just get the overall idea. So there are minor reactions inside both reactions. There are minor chemical reactions. Just don't think much about that, but generally tell me, generally මොකද වෙන්නේ? Screen එකේ color එකක් display කරන එක physical ද chemical ද? Print එකේ color එකක් display කරන එක chemical ද physical ද?
Sir, printer එකේ chemical.
Screen එක physical.
Yes, sir.
Okay. In printer, chemical, in screen. Okay. Kind of. Yes. Why? Because in printer, you have ink. Right? We are mixing ink. We are mixing ink. And how we are doing this? Just by using chemistry. It's chemical reaction. That is true. We are mixing ink. That is chemistry, chemical reaction. And through that, it forms colors. Right? So that is happening. This liquid ink is basically mixed with some other liquid ink, and using that, colors are created. So it is chemical. On the other hand, in the screen, light is used. So light is used, light is mixed with some other light, and new light or new version of light or new illumination or new color will be displayed. That is physical. That is actually handling light. So in the printer, it's handling ink, screen handling light. Okay, so let's further explain this. So when you break down a paper, when you tear a paper into small pieces, the paper is torn into small pieces, right? Paper is torn into very small, tiny particles of paper. So still that is paper. After tearing, still that is paper, right? You can see small parts, that is true, but the composition has not changed. So what will happen after tearing off? So after tearing, still you can see it is paper. So these things are called physical changes. You can see, you can observe some change, that is true. The paper is torn into pieces, that is true, but still it is paper. So in tearing the paper, composition of that has not changed. Composition is how it is made up with, the smallest particle or smallest compound that is made up with. It has not changed, still it is paper. It is showing the same properties. It is showing the same properties of paper. So we call that physical changes. Similarly, when colors are mixed and displayed in the screen, after some time, you can get these pixels back again. That these pixels can be recovered. These pixels can be taken back. Actually, what has happened that time, due to some illumination or due to some change or maybe mixing up, it has displayed something, but physically, the thing is, it has not changed the format. Still, those are pixels. Still, those are LEDs. Maybe still those are transistors, something. So those pixels has not changed. Therefore, we call that a physical change. But the other hand, when you are burning a paper, then what will happen? When you are burning this paper, changes of composition will occur. Why? After burning this paper, you will get ash and smoke. It is not the same thing. You will get ash and smoke, and it is not the same thing. Therefore, we call that as a chemical change, because whatever you had earlier is paper. After burning, what you can see is ash and smoke. It is not the same. It is not showing the same properties as previous. Therefore, it is called a chemical change. Okay, can you give me a few more examples for chemical changes? A few more examples for chemical changes, please.
burning firewood.
Burning firewood.
Firewood.
Burning firewood, okay. Only burning. So tell me some other things other than burning. Yeah, that is correct. What you said is correct, because it will keep some charcoal and ash and all. Yes, some other, please, other than burning firewood. So don't just think about burning. Chemical reactions that you can see. Chemical things that you can see. Not physical, chemical things that you can see. Just think about the environment. Just think about what is happening in the environment.
Sir, හුණුදිය කරාම
හුණුදිය කරාම මොකද්ද වෙන්නේ? හුණුදිය කරාම ඔව් හුණුදිය කළා මෙහෙමයි කාබන් ඩයොක්සයිඩ් වගේ යවුවොත් නම් අර හුණුදියල කිරිපාට වෙන එක ගන්න පුළුවන්. ඒක කෙමිකල්. එතකොට කම්පවුන්ඩ් චේන්ජ් එකක් වෙනවා. That is true.
බයෝගෑස්
Hello? Yes?
සර් බයෝගෑස් ගන්න බැරිද?
මොකද්ද පුතේ?
බයෝගෑස්
Biogas, yes. Yeah, a lot, right? Biogas, acid-based reactions, right? Acid and base reactions, which is like what is happening inside our body. Think about when we eat, when we swallow things, when we eat things, what is happening inside our body, the energy formation, and in our body there's acid, and that will basically digest the food, right? It will burn the food and produce oxygen. Likewise, so there are things happening. Right, so that is acid-base reactions. Generally, acid-base reactions are happening, and then not just that, maybe the environment, so the photosynthesis, which like basically these plants produce food that way, food digestion, and different things are there, right? So all these, most of things are, you can see. Most of these things are chemical reactions. Can you give me a few examples for physical reactions then? Physical reaction, remember that the physical reaction, what will happen? It will not change the original format of the compound that is made up. Physical, no chemical change, just physical. So what, can you tell me few physical reactions? Quickly.
ice
You mean like melting ice?
yes sir.
Yeah, melting ice can be taken because like it's not changing the format. Still it is H2O. Still it is ice. Yes, anything else? Anything else? Only that. So what about dissolving salt or sugar in water? Is it physical or chemical? Dissolving salt or sugar in water.
Physical.
Why? Isn't it changing the format?
It dissolved in water.
Yeah, it dissolves, but still it is there, right? It is there as it is. It dissolves. But if it is like, if it is dissolved in some other, maybe if water is dissolved in maybe acid water, acidic water, if if this what sugar is dissolved in acidic water, then that can be a chemical reaction. But in normal water, so there will be no reaction other than dissolved. Okay, now I think you got the idea. So if the composition of matter is not changing and no new substances are formed, then we just name this as a physical reaction, right? But if there is a composition change and if there are substances, new substances, so made or new bonds are there, so then we call that as a chemical. Okay, so see here. So this is an example of dissolving salt in water. So you have to take a beaker, water, salt, and tripod, spirit lamp, and the Bunsen burner. So what you need to do is you have to dissolve take some amount of salt and dissolve it in water. Like you can take a very small amount because otherwise it will take a long time to burn and reduce the saturation. Reduce the water level. So it will take some more time. Therefore, you can take very small amount of water, like 50 milliliters, even 25 milliliters. It's okay. Then what you need to do is you have to use a teaspoon of salt and dissolve it properly. Then keep increasing the temperature and use the Bunsen burner and try to completely remove water. So water will be vaporized. Try to completely remove the water, and so what will remain? The remaining will be again salt. Right, that is like what you have previously dissolved, so you can see it again. What you have previously dissolved, that you can see it again. So therefore, this is what? This is a physical change. Okay, here another one, another example. You can see the magnesium ribbon. I think you have done this in your lab, maybe. Magnesium ribbon. What happened when you burn the magnesium ribbon using a lamp? Don't just see this. Just tell me. Magnesium ribbon, what happens if you burn this using a Bunsen lamp? Yes, will it burn and what will happen? Any idea?
It become a powder.
Yes, it will become a powder. It will become a white color powder. That is basically forming, we call, it forms magnesium oxide. It will react with oxygen, and as a result, magnesium oxide will be formed. And so this is that practical. A magnesium ribbon and candle or street lamp you can use, and you can take the magnesium ribbon. Don't touch this. You can use this. You use a small, like you have to hold this. Don't hold use in your hand. You have to use a spirit. This one, and then that is like metallic lasher, and then magnesium ribbon will be burn with a bright, very bright flame. So very bright flame will be, and that will produce white powder. Actually, that is called magnesium oxide, right? Magnesium oxide. And actually, this is not a day-to-day reaction, but after that, so earlier it was magnesium, but after that you can see magnesium oxide. That is not the same. So since magnesium and magnesium oxide are not the same, there is a change of matter, change of compound. So we call that a chemical reaction. So this is an example. Okay, as you can see, burning magnesium ribbon is a chemical change. Changes we experience in the day-to-day life can be divided into two types: physical and chemical changes. Okay, so there are, now you can see, so please write down this. Right, please write down this 8.1 in your book. So write the topic. Topic is changes in matter, and under that 8.1 quickly write down. Then classify these things into physical and chemical changes quickly. So which is chemical, which is physical? Just write down. Just divide this to table, right? Just write down in a table. One side you can write physical, the other side you can write chemical, and divide this into the table quickly. And send me the one to WhatsApp very quickly after drawing this. Melting of solid wax. Still it is wax, right? Therefore it is, you can call it a physical change. That is correct. Vaporization of water, yes. Still it is water. Melting of ice. Breaking granite into pieces. Still these are granite pieces, right? So all these are physical changes. Yes, correct. Chemical changes. Rusting of iron. Rust is basically ferric oxide. So again, there is a reaction. So the matter, the status will be same, but the thing is there will be a compound change. Therefore, we can call that a chemical reaction. Burning camphor, yes. Burning firewood. Lighting a tracker, yes. There will be those, all these are reactions. We can take this as chemical. Right, therefore, right now I think you have identified the physical and chemical reactions very well, or the changes. Right.
Excuse me, sir.
Next is these special words. Actually, these things again we have learned in previous chapters, sorry, previous grades, but let me remind you this again. So when you change the status from first you are changing the status from gas, let's say you are changing from solid to liquid. That is called fusion, or another word, you can write down another word is that is called melting or fusion. Fusion means changing the solid status to the liquid status. Melt kiyanna puluwan, fusion kiyanna puluwan. Think about ice cream, think about ice. So it is melting. At which temperature this is happening is called melting point. Okay. The next thing is change in liquid to the gas. Change in liquid status to the gas status. This is happening when you boil water. So that is called vaporization. That is called vaporization, change in liquid status to gas. Actually, so I would like to ask you another question. This is happening in the plants also, no? So I think you can remember when you, so there is a small experiment in grade 6. When you wrap a polythene bag around, leaves and keep it for few hours in sunlight, you can see the water drops in the polythene bag, or you can see some collected water in the polythene bag. So what is happening there? Is it vaporization and condensation, or is it something else? So there is a special name given for that. What is that? Why it is happening? I hope you can remember the scenario, right? Remember the practical. What you need to do is you have to cover a set of leaves using polythene, right? Polythene and polythene bag, and keep it for some hours in sunlight. Then when you monitor this after some time, you can see there are water drops, condensed water. Actually, what is the process? Is it due to boiling, or is it due to some other reason? Yes. එක වෙන්නේ boil වෙලාද වතුර නැත්නම් වෙන විදිහකටද? Yes.
Some other reason, sir.
Okay, then what is the reason?
උත්සේදනය.
Hari වචනේ hari. So what is the basically the English word? Yes.
Don't know, sir.
Transpiration, right? It's called transpiration. Let me show it to you. It is called transpiration. මතක තියාගන්න. හරිද? ඒක තියෙනවා grade 6 හැබැයි. Okay. Here, can you see? Evaporation is basically due to sunlight. The soil water or groundwater can evaporate. This happens due to sunlight, right? The precipitation is kind of rain, hail, ice වැටෙන එක, හිම වැටෙන එක, වැස්ස වැටෙන එක ඕන එකක් අපි ගන්න precipitation කියලා. Transpiration is from the plants, this water will be released as gas. That is called transpiration. උත්සේදනය. Evaporation from the soil, right? Transpiration from the leaves and sometimes can be from the stem. Precipitation is that falling down. These are also some other things happening around, right? Anyway, so that is also converting liquid into gas station. That can also be called vaporization, but the thing is, the more appropriate word is transpiration, right? The condensation is the other side. When this water vaporize or when this water transpirate, so that will be condensed due to cooling down or due to high humidity. That will be condensed back and the water will be created. That is what you can see in the bag after some time. Okay, rarely, occasionally, but this can also be happen. Solid can be sublimation to the gas. That means solid will be directly converted to the gas without converting to the liquid. Solid ekaparama gas වෙන වෙලාවල් තියෙනවා. We call that sublimation. So this is happening in the dye sublimation printers. Right? Sublimation printers, this is happening. So sublimation, actually there is a dye, dust, that will be sublimated to gas and transfers. That can happen. And freezing will convert liquid to solid. So then gas to solid conversion, what is that? Gas to solid conversion. There's a name given for gas to solid conversion. What is that? Can gas become solid quickly? So gas can be solidified, right? Gas can be solidified. So what it is called? The name is?
Deposition.
It's deposition. Okay, you can see here. Deposition and sublimation, right? Solid into gas conversion is sublimation, and deposition is basically gas to solid conversion. I think something wrong here. Yeah, correct. Gas to solid conversion is deposition. Yes. Okay, no. Yes, gas to solid, phase to solid phase. Yes, that is deposition. Please write down here deposition. The other side, solid to gas conversion. Solid to gas conversion is called sublimation. This also happens in the nature, right? This also happens in the nature. Okay, when hailing and all, when ice rain, hailing, so this happen. Deposition. Sublimation, basically ice can be vaporized directly. It can become gas in the air. This happens. Okay, with that we have discussed the basic status and the status changes. So let's discuss about the chemical changes. There's a small part to be discussed, I think. Yes. Anyway, so we have few topics. Yes, we can finish it next day, but it doesn't matter. So I'll finish that next day, right? Okay, then good night. See you next day.
Okay, sir. Good night, sir. Thank you, sir.